Okay, so welcome back. Let's do some examples. So let's look at the first one. So all we're going to do is we're going to use the relationship between inverse functions, right? So in this problem here, what they're asking us to do is they're giving us this. We know this to be true. And so we want to write this in terms of inverse sine, okay? So all we have to do is realize that if this, oh, by the way, we're looking at, again, we're thinking the restricted domain, right? So we're looking at the domain is between a restricted domain. Okay, so again, so assume that there is an inverse function and we're on a restricted domain so that it does satisfy the conditions for one-to-oneness. So if we know that sine of this angle equals this, then if I want to write this in terms of inverse sine, then what do? Well, you can either think through it and say, okay, well, if this is x and this is y, and if sine of x equals y, then inverse sine of y equals x. So you could think of it that way. Or if you want to put things in terms of inverse sine, then guess what? Just take the inverse sine of both sides. Okay? Remember, the principle of equality means that, hey, whatever I do to one side of the equation, I just need to make sure I do to the other side. So if I take the inverse sine, make sure I take the inverse sine of both sides, right? And so then I can just use the fact that they are inverse functions, right? So if I take the inverse of sine of 5 pi over 12, okay, which is less than a half. So this angle is between negative pi over 2 and positive pi over 2, okay? So we take the sine and then sine inverse, and then we take the inverse of the other side. Well, what do I get here? The sine inverse of sine undoes each other, and we get 5 pi over 12 is equal to sine inverse of 0.96593. And we're done. And so now we rewrote it in terms of inverse sine. Okay, now, what about this example here? Now here, in this example here, we're interested in exact values, not rounded values. So how do we use what we know about trig functions to help us find what the exact value of this? So now, one other thing you got to keep in mind. Inverse functions give you angles. You're looking for an angle. So this represents an angle. So the question I ask myself, and you should ask yourself the same question, is this. What angle? So this is an angle. So in other words, think to yourself that inverse sine of this is some theta. And so what I need to ask myself is, okay, if I was trying to do the other way, let's say use the inverse function, I ask myself, since I'm dealing with inverse sine here, I'm going to ask myself, the sine of what angle will give me 1/2? The sine of what angle will give me 1/2? So again, if you think about the unit circle, right? Or just think of the definition of sine, cosine, and tangent, right? And think of your right triangles, right? So I'm trying to find theta, and I want to know, hey, what the sine of what angle gives me 1/2? So how do I use sine? Sine means opposite over hypotenuse. So if I use 1/2, that tells me the opposite sine is 1 and the hypotenuse is 2. Well, that means if I use the Pythagorean theorem, right, then what happens? This is going to be the square root of 3. And so you immediately see what kind of triangle has these ratio of sides. And it's going to be a 30, 60, 90 triangle. In fact, this tells me that this is 30 degrees. Okay, or pi over 6. Now, since this is positive, remember what quadrants sine is positive in. Sine is positive in the first and second quadrant. So this could be pi over 6, or it could also be what? Well, 5 pi over 6. Right? So remember, when you go to the angles, there could be more than one angle that gives it to you. But remember, here's the key. Remember the restricted domain for sine. The restricted domain for sine is from negative pi over 2 to positive pi over 2. Okay? So guess what? That 5 pi over 6 is not acceptable, right? Because it's outside of the restricted domain. So in this case, it's going to be pi over 6. Okay, now, what about this one? Now, some of you may recognize these already, right? I mean, you should recognize these. So, square root of 2 over 2, right? Square root of 2 over 2, you should be thinking 45, 45, 90 triangle. Square root of 3 over 2, you should be thinking 30, 60, 90 triangle. Right? Because you see that square root of 3, right? Right? Oh, cosine, see? Okay? So, and 45, 45, 90 triangle. So you should already, I mean, if you practice these, you should be able to find out. And again, just ask yourself, the sine of what angle gives me this ratio? Well, in this case, what's sine? Opposite over hypotenuse, but this is going to be 1 over the square root of 2, right? If you think about it. So that's going to be a 45 degree angle, which is pi over 4. And again, we want an angle between negative pi over 2 and positive pi over 2. And so that's it. Now remember, again, there is a second angle, but again, it's outside the restricted domain. Now cosine. Now here, what's this? Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. So that means this is going to be what? Well, it's going to be a 30 degree angle again. But listen, it's negative. So I'm saying the cosine, so I'm asking myself, the cosine of what angle gives me negative square root of 3 over 2. Now, if it's negative, right, it's adjacent over hypotenuse. So that means this has to be negative, which means it's going in the negative x direction, which means we're in the second quadrant. Now, here's the thing. What's the restricted domain for cosine? It's 0 to pi. So, cosine is negative in what two quadrants? It's negative in the second and third quadrant. But the third quadrant, we don't think about it because, again, it's outside the domain. We're only interested from 0 to 2 pi. Or, excuse me, 0 to pi. So that means this is going to be what? The angle is going to be, it's going to be pi over 6, but in this case, it's going to be 5 pi over 6. Because the reference angle is a 30 degree angle. The reference angle is pi over 6. But since we have to be in the second quadrant, the angle is going to be 5 pi over 6. Okay, now, see, I like this. This is like a puzzle. I love these things because these are like puzzles you have to figure out, okay? And you're kind of putting the pieces together. Now, what about this one? Tangent. Now, tangent, inverse tangent of 1. So again, the question I'm asking is the tangent of what angle will give me 1? Okay, that's going to be a 45, 45, 90 triangle, right? Because again, tangent is opposite over adjacent. The only triangle, the only angle that will give us a right triangle that has that opposite over hypotenuse gives us 1 is a 45, 45 degree angle. So we know that it's going to be a 45 degree angle, but tangent is positive in the first and the third, the first and third quadrants. So we know this is going to be, the reference angle is going to be pi over 4, right? Okay, so, but here's the thing. What's the domain? The domain is negative pi over 2 to positive pi over 2, but it's non-inclusive, so it doesn't include the endpoints, okay? And pi over 4 definitely is inside that domain, that interval. And again, so that's why the third quadrant is out, because this range only goes from the first quadrant to the fourth quadrant, okay? And there you go. Have a great day.